Hello. For our first video in our counting series, we're going to be going over how to count lists of numbers, inclusive and exclusive, learn how to count multiple events, and we're going to learn how to do complementary counting. So let's get right to it. So first, let's start with why counting is important. So let's try this example. We have 10 pairs of shoes, 18 shirts, 10 pants, and 5 hats in our closet. If one outfit consists of one shirt, one pant, and one hat, and one pair of shoes, how many outfits can we have? So we can start by trying to list everything out. But the problem is that there are 9,000 possibilities. And you're going to have to list out all 9,000 of them. I'm not even sure you can do that in 2 pages of paper. So clearly we need a technique here, and that's what counting provides you with. So let's see how to count lists of numbers. If you're counting lists of numbers like 1 to 17, then you just have 17 numbers. But what if you want to count a list of numbers from a list like 3 to 18? Then you have to do something different. When a question says 3 to 18 inclusive, that means you include the 3 to 18 when you're counting. The formula for inclusive counting, if you're counting a list from A to B, is B minus A plus 1. Exclusive counting is when you don't count the 3 and 18, but count the numbers in between. The formula for exclusive counting is B minus A minus 1. So let's try an example. So we need to know how many numbers are on the list of 15 to 35, inclusive and exclusive. So let's try the inclusive first. So we have 15 to 35, and we know the formula is B minus A plus 1. In this case, the B is equals to 35 and the A is 15. So when we plug it into the formula, we have 35 minus 15 plus 1, which is equal to 21. So there are 21 numbers in the list 15 to 35 inclusive. Now let's try the exclusive. So we have 15 to 35, and the formula for exclusive is B minus A minus 1. So we can put these two values in again, and we get 35 minus 15 minus 1, which is equal to 19. So there are 19 numbers in the list 15 to 35 exclusive. Now let's see the multiplication principle. So if you want to count the number of ways things can occur simultaneously, there are 2 steps. First, you need to find the number of possibilities for each thing, then you just multiply them all together. The result is your answer. So let's try the example we tried before. You have 10 pairs of shoes, 18 shirts, 10 pants, and 5 hats in your closet. So if one outfit consists of one shirt, one pant, one hat, and one pair of shoes, how many outfits can you have? So the 4 things here are the shoes, the shirts, the pants, and the hats. So you've got 10 pairs of shoes, you've got 18 shirts, you've got 10 pants, and you've got 5 hats. So we've done step 1. Now step 2 is just multiplying this all together. And you get 10 times 18 times 10 times 5. And the result is 9,000. And now we've done step 2. So let's try another example. You have a pair of dice. How many different outcomes can you get? So there are 2 things here. Dice 1 and dice 2. So for both dice 1 and dice 2, we've got 6 possibilities of what we'll roll. So these are the 6 possibilities. So now we're done with step 1. Our next step is just to multiply them together, and that's step 2. And 6 times 6 is equal to 6 squared, which is equal to 36. So you can get 36 different rolls from a pair of dice. And we've done step. Now let's try complementary counting. So there are 3 steps in complementary counting. The first step is to find the total number of possible bets. Then your second step is to find the total number of outcomes that are what the question is not asking, or the opposite of what the question asks. For example, if you have red and blue marbles and the question is asking for a number of blue marbles, then you find the total number of red marbles, because that's the opposite of what the question is asking. Then your next step is to subtract the total outcomes by the number you obtained from the second step, and that's your answer. So now let's try an example. So we need to know how many positive integers less than 100 are not multiples of 3. So since there are many more integers that are not multiples of 3 than are multiples of 3, we can try to find the number of multiples of 3 and then subtract it by the number of possible integers below 100, because that's what complementary counting is. So first, let's find out the total number of integers from 1 to 99. These are the integers below 100, and we get 99 different integers there. So step 1, we get 99. Step 2, we need to find the number of multiples of 3 below 100. So the multiples of 3 below 100 are 3, 6, 9, 12, 15, all the way to 99. Notice that just 1 times 3, 2 times 3, 3 times 3, 4 times 3, all the way to 33 times 3. So what we're basically counting is just the list 1 to 33. So there are 33 numbers in that list. So there are 33 multiples of 3 under 100. So step 2 is 33. And step 3 is when you subtract step 1 and step 2. And your result is 66. So there's 66 integers less than 100 that are not multiples of 3. And that's your answer. Thank you.